Hi again. Welcome to the guided notes for homework and notes number 6. We're going to be talking about the remainder theorem. You noticed before when we did synthetic division that sometimes we ended up with a 0, as in these examples in 4 and 5. Sometimes we ended up with some sort of remainder. What that means, if we get a remainder, is that you just found the value of the function at that particular x value. So let's do some synthetic division here, and we'll use the remainder and the remainder theorem to fill in, to determine if the divisor is a factor of the polynomial. So I've got a root of 3, and then I've got a divisor here of 1, 0, and 9. Bring the 1 down. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. When I add those, I get 18. So x minus 3, but it should be a root. 3. Interesting. Okay. Anyway, oh no, it shouldn't be. This is right. So what this tells you is that f of 3 equals 18. So if I plug 3 into the function, 3 squared plus 9 does in fact equal 18. This is the remainder theorem, that what you get as a remainder tells you the value of the function at x. Okay, let's do another synthetic division here. We've got negative 3 plugged in, then I plug in 1. There is no x squared term, so I plug in 0 as a placeholder, negative 4, and 6. Bring the 1 down, it becomes a 1, negative 3, 9, 5, negative 15, and negative 9. So that tells me that f of negative 3 is negative 9. Sometimes this can be a faster way to evaluate a function, sometimes not, but it will, when you do synthetic division, tell you whether or not x plus 3 is a factor of x cubed minus 4x plus 6. It will also tell you the value. Okay, let's see. In the next video, we are going to factor the polynomial, right now we're going to factor the polynomial completely using synthetic division. So we'll take this polynomial, 3, 8, 3 minus 2. As I go in descending order, every exponent 3, 2, 1 down to 0 is accounted for. 3, 8, 3, and negative 2 are my coefficients, and negative 2 is my root. So as I work my way through synthetic division, I am, let's see, that's 2. I'm going to get a lesser degree polynomial that I can then factor or do more synthetic division with. So negative 2 times 2 is negative 4. I add those, I get negative 1. I multiply negative 2 times negative 1, I get 2. And I get a remainder of 0. What I'm left with here is 3x squared plus 2x minus 1. Let's see if we can factor that, or we could use the quadratic formula because it's a quadratic. So, let's see. Let's take 3x squared plus 2x minus 1. Let's set that equal to 0. And let's see if we can factor that by product sum. So the product of two numbers has to be negative 3, and their sum has to be 2. I'm hoping that we can split that middle term. This is a factor by grouping, since the a term is something other than 1. Let's see. Let's factor those into plus 3x minus x. And then the minus 1 and the 3x squared come down. It looks like this might work out if I try to factor by grouping. I've got x plus 1. If I take out a negative 1, then I've got x plus 1. All that equals 0. So now I've got 3x minus 1 as a factor and x plus 1 as a factor. So my roots are where x equals 1/3 and where x equals negative 1, and of course from my synthetic division before, where x equals negative 2. These are my roots. I have factored completely and found the roots. If you wanted to write this in fully factored form, it would be 3x minus 1 times x plus 1 times x plus 2. These are my factors. These are my zeros or my roots or my solutions. Okay, that concludes the second part of the guided notes video for homework number 6 on synthetic division.